Good morning, good afternoon, good evening, whenever you may be. It's time for another exciting live broadcast from the Brenna Bunker, deep in the heart of quarantine, Southeast United States. It's another installment of ACE Academy, 7th grade science. All right, folks, I hope you guys have been staying safe out there once again. And remember that social distancing. Even if you're outside running other people, try to stay, 6 feet away. Hey, if you're watching this video, remember to like the video, sign up on my channel, and make sure you leave a comment in the comment section that says hi or hey or I was here. That's how I'm taking attendance. So today we're talking about Earth systems and weather instruments. What's a weather instrument? We'll get to that. So I can explain how to collect the data that is used to announce and forecast the weather. So we use many instruments and technologies to allow us to explain the forecast of weather, from simple temperature readings to complex mathematical models run by huge computers, and the instruments we use are incredibly varied. If one wanted to know the weather right now, most people say, open a window and look out and see what you say. So if we did open a window, what could we tell about the weather? Well, we could see how the sky looks. Is it sunny or cloudy or somewhere in between? We could tell if it's raining, and we could see trees moving. If the wind was blowing, we could feel if it was warm or cool or cold. But if I'm from New York and my friend's from Florida, my idea of warm and his idea of warm are completely different. So I can't just say, well, it feels warm. And my friend would go, oh man, it's freezing. Because our ideas of what those words mean are different. So you have to kind of get information to a point that when you tell it to somebody, they know exactly what you're talking about. And that's why we use things like temperature and barometric pressure and sky coverage. And because those elements are the same no matter where you are. Temperature is the temperature no matter where you are. So if they say it's 75 degrees and you're from New York, you're like, wow, that's pretty warm. If they say 75 degrees and you're from Florida, you're like, it's kind of chilly. So, but you both know what it is. It's 75 degrees. So this is why we have a device to measure air temperature and many of the conditions we experience outside. The basic weather instruments are the thermometer for finding air temperature, the anemometer for finding out the wind speed, the wind vane for finding the wind direction, the rain gauge for calculating how much precipitation has fallen, a hygrometer to measure humidity, and the barometer for measuring atmospheric pressure. So those are the basic instruments. So these instruments we need to know. You need to know these, all of these. Somebody asked you, what do you use to find the temperature? A thermometer. What do you use to find the barometric pressure? A barometer. What do you use to find the amount of rain that has fallen? A rain gauge. Those are the kind of things you need to be able to spit out and people somebody ask you those questions, specifically on an assessment. So you can actually have all these things literally in your backyard if you'd like to. There are a number of companies that will sell different setups like these. They're almost quote automated weather stations. In fact, this one right here actually reports to Weather Underground. We've talked about this one before, and we'll give you literally readouts. And this one will broadcast not only to a device you can put in your home, but it'll actually set up a little almost a web use that you can get on your device any place you are. So no matter where you are, you literally can call up your own house and go, hey, what's the weather at my house right now? And it'll tell you the temperature, the pressure, the wind, where the wind's coming from, how fast it's gone. And these things can even include what they call a lightning detector. And you can tell if there's a thunderstorm within 25 miles, which is pretty cool. You do have to kind of get them up in the air. So you see this one's actually mounted on somebody's roof. There's a chimney. To have accurate readings. So it's not something you just like plant on the ground in your backyard, because if the trees and everything else interfere with it, you're not going to get a true reading of what the wind speed or direction is. That'll be very variable and not a whole lot of interesting information. But get up on your roof and up in the to where it's free to sense the actual what's going on. And yeah, it does give you some information. So now we have a lot of information about our basic weather conditions. So we know the temperature, the air pressure, the amount of rain received, wind speed, direction, humidity. What else can we find out about the atmospheric conditions right now? Some more of the advanced information and instruments are available as well. So if you're a pilot, and remember I came from, worked in aviation for a number of years. If you call the automated weather station at an airport, you can get things like The present weather sensor, so is a component of an automated weather station that detects the presence of hydrometeors. There's an interesting word right there. Um, if we talk about radar and everything, hydro is what? Hydro is water. Meteor, well, that's one of those usually things that's falling flaming from the sky, right? Well, it's not flaming, but if it's a water meteor, it's basically a raindrop. It's a very scientific term. Once again, scientists, when they create things or name things, you get to name it what you want. He named it, whoever came up with this term, hydrometeor, otherwise known as a raindrop, but it detects the presence of hydrometeors in terms of type: rain, snow, drizzle. So it can tell you how fine, whether it's pouring cats and dogs or just barely coming down. So it works on a similar principle to bistatic radar. Don't worry about the word bistatic. Bi means two, static means not moving. Radar using light, energy to scan things and reading the bounce back of energy, noting the passage of droplets or flakes between a transmitter and a sensor. Now, here's the next thing: a transmissometer. So we have the present weather sensor. Present meaning current, right? We have a transmissometer. We have a disdrometer. Before I get out of this, and a celiometer. So a transmissometer is an instrument for measuring the extinction coefficient of the atmosphere. Wow, extinction coefficient. Extinction means something dying out, right? Well, in this case, it's the dying out of light. So they use a laser. Basically, they shine a laser between an emitter and a target. And based on how much of that light energy the target receives, they can tell the visual range, how much cloud is between the emitter and the target down there at the ground level. So it's one of those, they call it runway visual range. So basically, when your wheels touch down, how far are you going to be able to see? So it's real helpful when you're trying to determine if there's fog or things like that. So if the rain's coming down, those raindrops will actually interfere with your ability to see as well. So a transmissometer basically tells you how far you can see. A disdrometer is an instrument for measuring the drop size, distribution, and velocity following hydrometeors. There's that word again, raindrops. So it tells you the size, distribution, how many of them are in a certain space, and velocity, how fast it's coming down. So, and then some of them can differentiate between rain, grapple. There's a word you don't see every day, right? Grapple. Wow, what does that mean? Copy. Obviously, some sort of weather phenomena. Well, let's go find out. Grapple. Geez, translate to English. Oh, sleet. Ah, you know what sleet is. Soft hail, snow pellets, sleet. Okay. Grapple, soft hail, sleet, effectively, and hard hail, which is just hail. So rain size, drop distribution. So basically, this thing tells you how hard it's raining right now, not just is it pouring? Um, so it's again more information, the more effectively we can tell you what's going on. And then last thing is the celiometer. Device uses a laser or other source to determine the height of the cloud ceiling or cloud base. Celiometers can be used to measure the aerosol, like spray a can, you see that little mist, aerosol concentration within the atmosphere. So this tells you how low the clouds are or how high the clouds are. So when you see that, there's puffy clouds, and like, how high is that cloud in the sky? A celiometer can tell you how high that cloud is, up to about 10,000 feet. Typically, you'll get an automated weather report if they're using celiometers. They'll say, clear below 10,000. So the atmosphere that's about as high as those things will work, but 10,000 feet. So these instruments are used at airports primarily to help pilots approaching the airport to know what conditions to expect when landing. But that information is always plugged into the weather service computers, and so they take that information into account when they do their forecast. But we'll talk about forecasting tomorrow. So more weather instruments. Yeah, keep going down. So another instrument used to describe the atmospheric conditions currently is weather radar. So everybody's seen weather radar pictures. So weather radar is a beam of radio energy that's transmitted into the air, and when it hits rain droplets on the ground, signal bounces back to the receiver. It is shown on display as rain over some area ground. Now it's like, all right, how did we come up with weather radar? Well, guess what? A lot of these things that we get come from the military, and so this is another one of those ones that well, we invented radar back during World War II, 1940-ish or so, and we used the radar to try to find enemy airplanes in the sky to tell if they're coming to bomb us or attack us. So we used radar. But one of the things they kept running into is that a lot of times, if there was weather in the area, they wouldn't see the bombers. They'd just see big masses. And again, these aren't the nice, pretty pictures we see like these days. They were very old fashioned, looked like a game of pong. It's just blips and splotches on a screen. All they could see was a big splotch, and it was basically rain. But of course, during the war, we like really don't care about the splotches. We want to find little dots that are airplanes. But after the war was over, those guys kind of went, "Hey, wait a minute. If we can use this radar and it sees rain, that actually might be useful to people who want to, tell you what the weather is. If we can see rain before it actually gets here." So they started working on it and came up with different radar systems that actually were designed to look at rain. And so there's for our radar systems that we use today to see rain come from. And you've all seen these kind of pretty pictures like this. They do look kind of pretty, except for the fact that, when you see this red and even this pink in here, somebody's getting the stuff knocked out of them by some severe weather. You see this little symbol, that little thing right there, and you see this one right here. When you see things like that, those are what they call a hook signature. And when people talk about, the radar has indicated a tornado or possible tornado, that's what they're looking at on the radar and going, oh, wow, that could be a tornado. Because what happens is, tornadoes spin. As they spin and become, relatively, built up, they actually suck the rain, because this is all this is looking at is how much water's in the air right there. Now there are some that start looking at what they call vertical velocity, how fast something is moving up and down. And so there's those two. But for right now, I mean, this picture is looking at sheerly the amount of water that is occurring at the particular altitude that this weather radar is aimed at, and they see this. So, this thing curling around like that. Here's another one right here, curling around. So you got crazy, crazy high amounts of rain right there, and it's being kind of right. It's like, oh, wait a minute. Wow, that doesn't normally look like that. Well, if there's a tornado forming right there at the backside, of a storm, that's what a tornado looks like on radar. So when you get these reports, here's another one right here. So these two are the same thing. They're just different pieces of different information they're looking at. There's that thing, and there's the hook again right there. Looks like a hook. That one looks like a question mark. See, there's a question mark. Question. It looks like it's called a hook signature, and that's what they look for when they're talking about tornado signatures on radar. Yeah, here's the one. Excuse me. Again, we have more, and a line of storms. And when you see this red, the darker yellow, those are thunderstorms. Because when you're carrying that much water in the atmosphere, and the pink specifically, the pink would typically what they call a supercell. When you see a line of red like that, it's a line of thunderstorms. Typically, when you see something like that, I mean, it's in a line like that, that could be a frontal boundary between, two different air masses. Again, the cold air is pushing the warm air that's in front of it. That warm air rises and causes, severe storms along that front. And in other cases, it's not really a front. It's just pop up, thunderstorms due to the, the thermal heating of the earth and, getting all that energy into the atmosphere, evaporating a lot of water, getting a lot of water vapor, a lot of heat, and you get this, pop up summer thunderstorms that are not associated with a frontal system, but they're just normal occasions of weather. So weather radar has become very important to us in our ability to tell us what's going on with weather. And lastly, one of the last instruments we have available to tell us what's going on is the weather satellite. So we take it. Weather satellite is simply an instrument that we've put in space to look down on Earth and take pictures in multiple formats and send them back down to Earth, be read and interpreted. Satellite images give us information on clouds and water vapor amounts, allow us to see what's happening in places we don't have ground weather stations, especially over oceans and stuff. So here's the satellite that's up here. Here's the Earth. We have two different types of orbits that we put weather satellites into. One's a polar orbit that kind of orbits, this way, and the other one's a geostationary orbit that sits there like that. Now, the thing about geostationary is, I mean, that satellite is far enough away from Earth that as the Earth rotates and turns on its axis like it always does, the satellite is going around at the same speed. So the satellite ends up sitting in the exact same spot above the exact same place on the ground in its orbit the whole time. So we have these what we call networks or constellations of satellites we've put up into the atmosphere, into the space, and they sit up there and they take pictures of the Earth with different instruments to tell us what the weather is going on. So we see one example of this. This is what we call an enhance. It's enhanced because we put the color in and we give it the outline of the United States here. But this one, gives us uh, water vapor in the air. It's not telling us these aren't, like thunderstorms and rain, like the radar data, but this is the amount of water vapor that is in the air, in the atmosphere, that the satellite is seeing. And so by looking at water vapor, we can tell how much, the possibility exists for rain. If there's no water vapor, like here over Texas, you're not going to get any rain. Then you have water vapor in some places, and then you have lots of water vapor in places, and you're pretty sure that, yep, there's some rain going on in there because how much water vapor is there. And here's another one that's enhanced in a different way. And so this one looks like a thermal image. So here we got a tropical system of some sort orbiting here off of North Carolina's coast, because there's North Carolina. And we have another blow up of thermal energy here. So that's, a thunderstorm base effectively. Here's some, pumping that hot air from the ground high up into the atmosphere to the point where these satellites can pick it up and image it, along with a simple satellite cloud picture that we can see. And so it overlays the thermal data with the cloud data, and it shows us this, these systems that are very active. So when you have a high amount of thermal activity, especially at altitude, that a satellite can pick it up, that tells you that that's a very intense or going to be a very intense kind of storm. And then here, we talked yesterday about hurricanes as severe storms. Here's the west coast of Africa. Here we are, South America, down the equator's down here. So here is that intertropical convergence zone. Remember that thing I was talking about yesterday? Here's the intertropical convergence zone, and here's a couple of circles. Here are these waves of energy of pressure, tropical waves coming off the west coast of Africa, because the air circulates like this, and this round and around and around like this, and in the Atlantic. So air is going west here, circulates this way, goes east here, and then it comes down and goes west, like that. So here's these waves coming off the west coast of Africa, and these are those tropical waves that we have to kind of watch out for. And we use satellite data to be able to see these things, because there's no weather stations down here. There's no, because it's over the water, and it's deep enough that you can't like anchor it. So the only way you could, you have a buoy floating around out there, just kind of aimlessly following the ocean, but it would eventually move to a place that becomes less useful, and so you have to keep dropping them in the area to keep watch over an area. So we use satellites to watch these areas in the ocean where we don't have weather stations report what's going on. So now, but that is one of the things that we're actually kind of working on, and this is one of the things going forward. Many people are still trying to create more and better weather data to help us understand our environment, whether it's the next generation of radar, satellite, unmanned sailing drones, weather stations aboard. Weather's still an evolving science. There's a company that has these things called sail drones, and it's a drone sailboat that sails out into the ocean and collects weather data. And it's got solar panels on it for energy, and it reports this, data to a satellite. It's got a little satellite uplink up here, and reports satellite, weather data, current air temperature, current sea temperature, which is important, especially if you're talking about hurricanes, because the warmer the water, the more powerful a hurricane that, or weather system that could form, that could potentially form into a hurricane, can get in that area. So these things are basically seaborne, solar powered drone weather stations that are piloted, remotely from their offices back here in the United States. Now, unlike a airplane drone, which needs constant monitoring, these things kind of are autonomous, as you would say. They kind of power themselves and guide themselves with basic, hey, turn this way, hey, turn this way, go to the spot information from humans back at home. But they keep reporting the weather data back to home, and it helps us really nail down what's going on out in the ocean where we wouldn't really have data from. So again, add more data. The more data we have, we can take our computers and crunch that data. And tomorrow we'll talk about what we do with all that data to talk about the weather coming up. All right. Hope everybody's had a great lesson. Enjoyed this lesson. Once again, make sure you check in at the bottom. Say, hey, I was here. Give a like to the lesson and sign up for the channel. And we'll catch you guys tomorrow. Hope you have a great one. Stay safe and 6 feet away.